Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.7, day 1, entitled Inequalities. And today we're going to be talking about a few different objectives. We're going to be solving linear inequalities, and we're also going to be solving compound linear inequalities. And then we're going to take a look at nonlinear inequalities as well, and those are the quadratic and the rational inequalities. Now, when we're solving algebra problems, sometimes we don't always have an equation that we're solving. Sometimes we have a situation where the quantities are less than or greater than, less than or equal to, or greater than or equal to each other. So this is just an example of an inequality. It's an equation that instead of an equal sign has an inequality sign. So instead of having one exact answer, inequalities have many correct possible answers. So as you can see in this table, 1 would be a value that if we substituted it in for x, 4 times 1 is 4 plus 7, that's 11. 11 is less than 19, and that's a true statement. So there are several values. Looks like everything equal to 3 or less than 3 gives us a true statement for that inequality. So when we're solving an actual inequality that contains a variable, it means to find all of the solutions that make the value, or all of the values of the variable that make the inequality true. And we can represent this graphically as well. If we have an equation, we represent our answer as just one location on a graph. But if we have an inequality, we're going to have our open and closed circles, and we're going to shade either above or below or between or away from those points on the number line. And this table here is just some reminders of some rules for inequalities. This is in your book as well. And we know that we can add and subtract numbers to both sides of an inequality as we're solving it. But we want to pay special attention to number 3 and number 4. Number 3 and number 4 tells us that if we multiply by a positive number on both sides, that's okay. But if we multiply by a negative number on both sides of the equation, then we have to switch our inequality sign. And that was something that we've already seen on one of our quizzes, and some people were overlooking that rule. So we really want to make sure we're aware of that today. And this is just a reminder of that. For Rule 3 and Rule 4, it says that if we multiply both sides of an inequality by a negative number, then we have to reverse the direction of the inequality sign. Okay, so let's take a look at our first few inequalities here. And an inequality is linear if each term is constant or a multiple of the variable. So linear just means that we have one variable. We have an x. We don't have an x squared or an x cubed. So in this first example, we have part A and then we have part B after this one. And this is just solving and graphing a basic linear inequality. This is just to refresh your memory on how to solve them and how to graph them. And we're also going to take a look at how to write our answer in set notation. So for our inequality here, we have 3x is less than 9x plus 4. We want to get all of our x's, all of our variables over to the other side. So I'm going to subtract 9x from both sides of my inequality. And that will get me negative 6x is less than 4. And then here I am going to divide by a negative number. So that means I have to switch the direction of my inequality sign. And I do want to reduce my fraction. So I'll have negative 2/3 here. So usually in the past you kind of stop there and that's your answer. But remember, now we have to practice with our set notation. So basically that means you just take your answer and you put it in those squiggly brackets with the variable that you're using and then that line that means such that. So this means your answer is a set of all values for x such that x is greater than negative 2/3. And I'm going to graph this first before we start talking about our other way to write our solution with the parentheses or the brackets. Okay, if I graph this, we want to remember that we've got some positives and negative numbers, or integers, on our number line. And negative 2/3 is going to be between 0 and negative 1. It's going to be right about there. And since we have just the greater than, I don't have that equal to, I'm going to mark it with an open circle on my number line. And then I'm going to shade to the right because that's where everything greater than negative 2/3 is. So that's how I would graphically represent my solution. So my solution really starts at negative 2/3 and goes all the way to positive infinity. So the other way that I could write my solution then would be parentheses negative 2/3 and then comma positive infinity with a parenthesis. Remember when we saw the set notation earlier in the chapter? We use those open parentheses anytime we had an open circle, and with infinity, either positive or negative, that always gets an open parenthesis like that. Okay, now for part B, this is a compound inequality, meaning that it has two inequalities in it, and our variable is in the middle. So these, when you learned them before, you kind of learned that they were either and or compound inequalities, meaning that you either shaded between your two answers or you shaded in opposite directions from your two solutions. And depending on who you had for an instructor, they might have had you break this apart into two inequality statements, solve each of them, and then put your answer back together. But I'm going to show you a faster combined way to do this. So we have negative 3 less than or equal to 3x plus 7 less than or equal to 1/2. Now I have to isolate the x. I have to get it all by itself. So I have to undo my adding 7. And I'm going to do that to all three parts. So now I have negative 10 less than or equal to 3x less than or equal to, now 7/2 is really like 14/2. And then if I'm adding 1/2 to it, that's going to be like a negative 13/2. So I'm just going to leave it an improper fraction for now. And then my next step is to divide by 3. So then I'll have negative 10/3 less than or equal to x. So now I have that x isolated, which is good. And negative 13/2 divided by 3. Remember, that's like multiplying by the reciprocal. So it's kind of like my multiplying by 1/3. So that's going to be negative 13/6. And we can leave our solution like that. And again, you could do your squiggly brackets, x, such that negative 10/3 less than or equal to x less than or equal to negative 13/6. If you want to write them as mixed numbers or if you want to write them as decimals, that's fine. And if I was going to graph my solution, let's see, I need to go probably about negative 4, negative 3. Let's see, negative 10/3 is about negative 3 and 1/3. So a little bit more than negative 3, and it's equal to, it's a less than or equal to, so I'm going to shade that circle in, make it a solid circle. Negative 13/6, that's negative 2 and a sixth, so a little bit past negative 2. And again, that's going to be a solid circle because I have the equal to. And then my x value is between those two, so I'm going to shade between. And I could also write my solution as an interval with the brackets. I would start at negative 10/3 and go all the way up to negative 13/6. And I would want closed square brackets there because I have solid circles. Now, when you learned this in the past, you learned that these are the and type of compound inequalities. And when you have those, you're going to shade in the middle. You're going to shade between your 2 points. What we're going to talk about in our next example, though, is how we could shade based on testing points. So I could take negative 4 and substitute it back into this original problem. And I would find that negative 4 does not give me a true statement. So I'm not going to shade in that region on the number line where I got negative 4 from. But then I could pick another number like negative 3, substitute that back in to the inequality. Let's see, 3 times negative 3, that's a negative 9, plus 7, that would be a negative 2. So negative 3 is less than negative 2, which is less than 1/2. That's a true statement, so I'm going to shade where I got the value negative 3 from. And then I could pick another value to the right, like I could pick negative 2 or negative 1 or 0. Let's just pick 0. If I substituted that in, then I would get negative 3 is less than 7 is less than 1/2. 7 is not less than 1/2, so I'm not going to shade in that region where the 0 came from. So I can also figure out where to shade by testing a few points from my number line to see if they give me a true statement or not. And I want to shade where I get a true statement. And this is exactly what I just discussed about how you can make a graph using test values. And again, we want to make sure we're writing our answers in set and interval notations. Okay, so now let's look at some more complicated nonlinear inequalities. And again, we're going to use this testing point idea to help us graph. Because now we're going to have quadratics, or we're going to have fractions, or we're going to have radicals. So we need to really make sure that we're accounting for all possibilities. Basically, we want to make sure that we get all terms on one side of the inequality sign. That is key when you're doing these. Even when you have a problem, like we're going to see examples A, B, and C coming up. In part C, it kind of looks like a proportion. You could be tempted to just cross multiply, and that would be fine if it was an equation, but it doesn't apply when you have an inequality. You have to make sure that you get everything set equal to 0. And then we'll factor if we need to. We'll find our intervals, and then we'll make a little table or a little diagram, and I'll show you kind of a shortcut for doing that. And by solving it, that means graphing it on a number line and writing your set and interval notations. Okay, so for example 3, part A, we're going to solve our inequality. And again, very first thing we have to do is make sure it's all set equal to 0. So I want to keep my x squared term positive, so that way I'll be able to factor. So I'm going to subtract the 5x and add the 6 over to the other side of my inequality. And now I need the factors of 6 that are going to add up to a negative 5. So I need an x and an x. And then the factors of 6, let's see, a 3 and a 2. If I multiply them, they will multiply to a positive 6 if I make them both negative, and then they will add to a negative 5 if they're both negative. So there we go, there's our correct factorization. And then what we did before when this was an equal sign was we set each of these little factors equal to 0 and we solved. So just for now, I'm just going to kind of think of it that same way. I'm going to think x equals 3 would be my restriction, and x equals 2 would also be a restriction on my domain. Now, how I'm going to use those numbers is those are going to be my values on my number line. 3, 4, 1, 2, 3, 4. And that's where I'm going to kind of begin my test points, okay? Those are going to be my solutions to my inequality. I want solid circles here because I've got the less than or equal to, so I want solid circles on 2 and 3. But now I just have to see if my solution is going to be to the left and the right of 2 and 3, or if it's going to be in between the values of 2 and 3. So here's how we're going to do that. Kind of below your picture, we're just going to make a little table. And I'm going to substitute some values into the x minus 2 and then the x minus 3. And then we want to think of it as a product as well, but we're not actually going to multiply. We're just going to use our signs. Okay? So now if I took the value of 1 and substituted it into the x minus 2. I'd have 1 minus 2. That'd give me a negative value. If I put 1 into the 1 minus 3, or x minus 3, 1 minus 3 is negative 2. That's a negative value. Okay? So I'm going to pick values that are to the left of 2. So I just picked 1 because it's a nice whole number. Now I have to pick a value in between the 2 and the 3. So let's just pick 2.5 because it's an easy value. You could pick any value you want. If you want to pick 2.9999999, that's fine. I'm just going to pick 2.5 and substitute it into these little expressions. So 2.5 minus 2, that's a positive value. 2.5 minus 3, that's a negative value. And then I'm going to pick some values to the right of 3. So I'll just pick 4 since it's the first whole number after 3. So 4 minus 2, that's a positive. 4 minus 3, that's a positive. So now basically what I do for this last row is I multiply those signs. 2 negatives make a positive. A positive and a negative make a negative. And a positive and a positive make a positive. So where I want to shade is where that value is negative. Okay? Because I had a less than inequality. So I want that negative value. I want that value that's going to be, since this would be a parabola, I want that part of the parabola that is less than or below my x-axis. And that's going to happen here between the 2 and the 3. So then if I wanted to write my answer in set notation, now that I know that I'm shading between the values, I could say I want all the x's such that 2 is less than x is less than or equal to 3. Or we could write it in our interval notation with brackets, 2 and 3. Again, this slide just describes how we made our table and made our graph with our test points. And this again is how we made our table. Okay, and all this information is in your book as well. And there they have both versions of the answer written out for you. Okay. So now, example 3 part B, we're going to go through the same process, except this time we have a fraction. So it's already set equal to 0, so we don't have to worry about that first step where we're setting everything equal to 0. So we have x minus 5 divided by x plus 3 is less than or equal to 0. And I can't really factor. Can't do anything to the numerator or the denominator to simplify them. So I just have to think what values x could be. And if I took that x minus 5 and kind of set him equal to 0, then I would have x equals 5. If I took the denominator, x plus 3, set him equal to 0, then I get x equals negative 3. And those are my values that I'm going to put on my number line to test. So I'm going to be down here at negative 3, 2, negative 1, 0, 1, 2, 3, 4, 5. And again, I want solid circles on the negative 3 and the 5 because I've got a less than or equal to. Now, you might remember that less than means and. It means it's an and compound inequality. So we're probably going to shade in the middle, but again, we're going to make that little table and we're going to test some values. So I'm going to test when x minus 5 is our value and when x plus 3 is our value, and then our quotient, x minus 5 over x plus 3. Then we multiplied in the previous problem because it was a quadratic and we had factored. So when you factor, you rewrite addition and subtraction as multiplication. Here, the original problem has division, so I'm going to divide here. So now if I test a value, let's just say I test negative 4. Negative 4 minus 5 would give me a negative value. Negative 4 plus 3 gives me a negative value. Negative divided by negative, that's positive. In between, I can pick any of these values in between negative 3 and 5. I'm just going to pick 0. 0 minus 5, that gets me a negative value. 0 plus 3, that's a positive. Negative divided by a positive, that's a negative. And then my last column here, I'm going to pick, let's just pick 6. 6 minus 5 is positive. 6 plus 3, that's a positive. Positive divided by positive, that's a positive. So you can see how this last row here, they have alternating signs. Okay, and I want to shade where we're dealing with negative because it's less than. So I'm going to shade between. So less than is and. And I could write my answer then in set notation, x, such that negative 3 is less than or equal to x is less than or equal to 5. Or I could write it in my interval notation. Again, we're using those solid square brackets because we have less than or equal to. We have solid circles. Those numbers are part of our solution. Okay, and that was just extra space if we needed it. And for part C, okay, now this is kind of the tricky one. This is the one that I told you previously where it looks like you could just cross multiply. And if this was an equal sign, we totally could just cross multiply and start solving. But because it's a less than, because it's an inequality, we have to make sure it's set equal to 0. So we have to make sure we do that first. So I'm going to add the 2 over to the other side. Because adding that 2 over is a lot easier to deal with than moving that fraction over to the other side. So now basically I have 2 fractions that I'm adding. So I need a common denominator. And that common denominator is going to have to be the x minus 3. So that first fraction is not going to change. My second fraction, though, if I want it to be over x minus 3, I'm going to have to multiply the 2 by the x minus 3. So that'll get me the 2x minus 6. And then I can write this all as one big fraction. If I combine my like terms going across my numerator here, I'm going to have 3x minus 5 over x minus 3. So I still have a division problem, but now I have one numerator and one denominator. And if I set each of those equal to 0 and solve, I'll get my 2 values that are going to go on my number line. So I'll have, let's see, 5/3. Then x minus 3 equals 0, so x will be 3. So I'm going to put 3 and 5/3 on my number line. And yes, you can have a situation where you have one number that's a fraction and one number that's a whole number. Okay, so I'll have 3. 5/3 is really what? 1 and 2/3. So 2, 1, 0. Here's 4. Okay, so I'm gonna, this time I just had a less than, so I'm gonna have an open circle on 3. And 1 and 2/3 is right about here. So that's where my 5/3 is at. I like to make number lines where I put all the whole numbers on there, and then if I have fractions or decimals, I label them where they would be in relation to those whole numbers. That's just personal preference for how I like to make my number lines. Okay, so I have my 2 values now, and I'm going to make my little table beneath it so I can test some points. And I'm going to test my numerator, the 3x minus 5, and the denominator, the x minus 3. And then I'm going to have the quotient, 3x minus 5 over x minus 3. So if I pick 1, or if I pick 0, and I substitute it in here, 3 times 0 is 0 minus 5, that gives me a negative value. 0 minus 3, that's another negative. Negative divided by negative, that's positive. Here I'm going to have a number between 5/3 and 3, so let's just pick the 2. 3 times 2 is 6, minus 5, that's positive. 2 minus 3 is negative 1, that's a negative. And then if I divide positive by negative, I get a negative. And my last column here, let's just pick the value of 4. 3 times 4 is 12, minus 5, that's going to get me a positive value. 4 minus 3, that's positive. Positive divided by a positive, that's still a positive. Now, here, I still have this positive, negative, positive pattern that I did before, okay? But I'm not going to shade between the numbers where there was a negative. I actually need to end up shading in opposite directions here where the positives are, because those are the values that if I substitute them back into the original problem will give me a true statement. So on my next page, I'm going to write my answer in set notation and interval notation. So when we have an or compound inequality, we have x is less than 5/3 or x is greater than 3. Whoops, 3. Your book might also write the or, instead of writing it as or, they might use the little union symbol. Let me go back for just one moment here. Now notice on the left side of my graph, I'm going from negative infinity all the way up to 5/3, and then I'm going to 3, or from 3 all the way up to positive infinity. So I have two little parts here that I need to include in my interval notation. I'm starting at negative infinity, so I'm going to have that open parenthesis. I'm going all the way up to 5/3, but I'm not including it in my answer, so I'm going to have another parenthesis. Or you could have the union symbol. And again, I start at 3, but I don't include 3 in my answer, so I need that parenthesis. And then I'm going all the way up to positive infinity. Now, in the past, when you've dealt with this problem, I'm going to rewrite it again. -2 less than, oops, sorry, just less than x plus 1 over x minus 3. Usually we get the 0 over on the right side of the problem. So if I did that, I would have to move this whole term, this x minus 1 and x minus 3, I'd have to move that over to the other side. And then the 2, I would have to move that to the other side. So when we solved it, we had the 0 here, x plus 1 and x minus 3, and then we had the plus 2. But traditionally, we put the variable on the left side, so then we'd have to flip-flop everything around. We'd have to have the x plus 1 over x minus 3 plus 2 greater than 0 if we wanted to rewrite it. Okay? So when your problem is written in this format, where you have your variables on the left and then your inequality sign and then the 0, okay, this is a greater than sign. And greater than signs usually mean that you get an or type of a graph. You get an or compound inequality. So again, that's why we want to shade in opposite directions there when we shade for our solution. Okay, so there is your homework, your practice set of problems to work on these concepts and these skills. Definitely practice making those tables and shading. You can use the tables, or you can use your knowledge of inequalities and an or compound inequalities from the past. And if you have questions, stop on in before school and see me.